Jai Hind all. Myself, Dr. Sarika, Associate Professor from AKGEC, Ghaziabad Institute. So today we discuss the architecture of electric vehicle. In the last lecture, we have discussed history of EVs, like what is the when we start the EV, when the EV comes in the market, and in 1980s it will started, then the IC engine will move off, then the electric vehicle, because it is cheaper and it is easily available. So but nowadays electric vehicles are very demanding vehicles by the industry, by everybody, right? So today we see the architecture of electric vehicle, what kind of vehicles are in the market right now, and uh, the architecture, right? So in this, if we see this, there is a four types of powertrains, EV powertrains. Like first is battery operated EV, that is BEV. Then hybrid electric vehicle, then the plug-in hybrid electric vehicle, and FCV, fuel cell based electric vehicles. So in the battery operated electric vehicle, that is, it is run only with the help of the battery operated. So it has only the electric motor which is operated by the battery, right? And the hybrid electric vehicle, it is the combination of the, if you see the architecture inside this hybrid motor, it is the main part of this hybrid vehicle is the electric motor as well as the IC engine. So and the plug-in hybrid electric vehicle, it is also have the electric motor, but the battery and also the fuel tank is also there in the hybrid electric vehicle. But if the battery is in the discharge mode, it can the vehicle can be run, and during the drive mode, the battery can be charged, right? So if the battery is discharged, the PHE electric vehicle can be drive with the help of the IC engine based fuel tank, because it has the both the combination, the IC engine tank, IC engine based, and the electric vehicle. But plug-in means, if the battery is discharged, then only you can run the motor with the help of fossil fuel tank, and during the driving mode, the vehicle can be charged, the battery can be charged, right? Fuel cell electric vehicle, it is based on the fuel cell, the chemical reactions takes place inside the, and that will run the motor, right? So the chemical reaction between the hydrogen and the oxygen. So this is you can see here, this is the fuel cell the hybrid electric vehicle, in which the fuel tank is there and the battery size is smaller than the plug-in hybrid electric vehicle, right? And the BEV, in which you can see that the only the battery bank is there, and the size of the battery bank is very much large in comparison to the hybrid electric vehicle or the plug-in hybrid electric vehicle, right? So in this, the the motor or the transmission process can be done with the help of battery, and this electrical motor can be run by the battery, and this transmission process also with the help of the IC engine. So it has a fuel tank that can be the ignition process takes place in the IC engine, and this will transmit the energy is transmit to the transmission, and the uh, the the vehicle will move. And also it has the electric motor which is the powered by the battery, right? Plug-in electric vehicle, it has the larger battery size than the hybrid electric vehicle, and it has the also the IC engine based fuel, the IC engine, the engine is there, and the transmission, the energy, the flow of energy goes to the transmission through the electric vehicle as well as the IC engine, right? In the battery operated electric vehicle, the whole battery is powered to the electric motor. So, if we see the comparison, so here we can see the battery electric vehicle, the driving component is the electric motor, and the energy source is also the energy source is the battery actually, and the features are there is a no emission because only the electric motor is responsible to run the drive. So, the energy is transferred and it is converted into the kinetic energy and the vehicle will drive, and so there is a no emission, and range depends largely on the type of battery used, right, and it is available commercially. So, problem associated with the battery vehicle, it's high cost actually, and the battery size is high, and the charging station is not yet established. So, availability of the charging station, and nowadays like the charging time is also the challenging thing. So, how to reduce the research is going on the how to reduce the charging time, and of course the range. In this, the range is also not up to the mark, like range to research is also going on how to increase the range of the EV, right. So, these are the problem right now associated with the battery electric vehicle. Now, if we come with this the hybrid electric vehicle, the driving component is, as I said earlier, the electric motor and the IC engine, and the energy sources are the IC engine as well as the battery. The battery is used to power the motor, and the IC engine takes place, the combustion process takes place in the with the help of this IC engine, and it will power to the transmission system. Features are very little emission because some of the energy flow through the electric motor. So, it's produces the emission, but the carbon emission it produces, but the in comparison to the whole IC engine based, it has a little less emission. It has the long range. This is the advantage, or you can say it's a feature that's have the long range, and it can get the power from the electric supply and the fuel as well as, right. A complex structure having both electrical and mechanical drivetrain, because it has both the this electric motor and IC. So, the architecture is a bit complicated, right. And the problem is associated how to manage the energy sources between the battery and the energy size engine size optimization. So, because in this you can see it has the battery also and the IC engine also. The both are responsible to provide the power to the transmission system. So, it is bit complicated than the battery electric vehicle, because in the battery electric vehicle you will see only the battery is there. So, only we have to manage this battery. In this we have to manage the battery as well as the IC engine. So, how to optimize the size of the IC engine, that is the challenging thing. Now, if you see the fuel cell electric vehicle, so it is driving component is the electric motor, and the energy source is fuel cell. So, it is also a very little or no emission is there, and the advantage is it is a high efficiency technology, and it is not depend upon the supply of electricity only. It is because the fuel cell is responsible to drive the motor, and it's a high price. It is the actually the drawback of this, and it is available commercially, right. So, what are the problem associated with a feasibility way to produce fuel, how to produce the fuel, that is the challenging thing, and fueling facility, if the fueling facility should be there, and the cost of the fuel cell. So this is the 3 points which is associated with this fuel cell electric vehicle, and this is the challenging things. Now, if you see the hybrid electric vehicle, it can be classified into 3 types: series hybrid electric vehicle, parallel hybrid electric vehicle, and the series parallel hybrid. It is divided on the basis of how the energy will flow from the input to the load side, right? So if you see in this diagram, this is the hybrid electric vehicle, parallel hybrid electric vehicle. So this is the battery bank. Through battery bank, it will power flow through the electrical, and finally it goes into the transmission, and the another power flow from the gasoline tank. So here the ignition process will be takes place, and the internal combustion engine will be there. So this is a tank, the fuel tank, and here the internal combustion engine will be there, and it will go to the transmission line. So energy flow from battery to the electric motor and the gasoline, the tank, or energy to the electric motor, if the both the energy are flowing parallelly and goes through the transmission, that is called the parallel hybrid. Hybrid means it is the combination of the electric motor and the internal combustion engine, right? And if the energy flow parallelly from the through the IC engine or the electric motor, this direction will flow, this will show the power flow. So it is power flow, and this is also the power flow from battery to the transmission through the electric motor. So it is parallelly energy flow, that's why it is called the parallel hybrid electric vehicle, right? This power flow is showing due to this, when the braking operation will takes place, then the power flow will be from electric motor to the battery bank, because of the when we are it is called also the regenerative braking takes place, right? So this is the hybrid series architecture, and this is the hybrid series parallel architecture. In the series architecture, both the energy, both the internal combustion and the motor or power bank system will be connected in series, and the power flow is from like this, in this way. You can see here this blue arrow, this in ignition, this will be connected in series, and the power flow through a IC engine, through a battery bank and the motor. So it will go into the transmission system. So both the system will be the IC engine or the motor will be connected in series. The power flow in this way. So it is called the series hybrid electric vehicle, right? In this series parallel, like you can see, this is the power flow will be IC engine through generator power flow. This is a series, and this goes to like this. So both series and parallel combination will be showing here. So this will give you the better result than the hybrid electric series or hybrid electric parallel. If you combine the series and parallel combination, the losses will be reduced, and the power flow will be we can improve the performance of the vehicle. Now we'll come to the architecture of this is a kind of hybrid electric vehicle architecture. It can be classified in 3, parallel as series and series parallel. Now in the electric vehicle architecture, this is the simple diagram of battery operated electric vehicle architecture. So it contain only the electric motor and the battery, right? And how to manage this battery, that is also matter, because what is the charging time, how the battery will discharge, how long the battery will charge, what the charging time is required to charge the battery. So this is a simple architecture. This is a four-wheeler vehicle, and it has the electric motor. So electric motor can be a BLDC motor, it can be a switch reluctance motor, it can be a the induction motor. Nowadays, the induction motor, the BLDC motor or the switch reluctance motor are the demanding motor for the electric vehicle, right? Because it provide the it fulfill the requirement of the torque of the vehicle, right? So this electric vehicle is electric motor is uh, uh, the power giving to the electric motor through the DC to AC inverter. So it has the main component of electric vehicle is the electric motor and the battery, right? And this battery will how to charge this battery, how to manage this battery. We need these kind of components or the converters, right? So this is the main component, and like suppose it is a BLDC motor, brushless DC motor. So but brushless DC motor always feeding through the DC to AC inverter, right? So and this DC can be achieved with the help of this battery bank, or this is the charger, right? How to charge this battery? This is the charger, and this charger can be a onboard charger of the or the offboard charger. Onboard charger means it is inside the vehicle. Offboard charger, that means it is outside the vehicle, right? So if you see from here, you can see that this is a grid, and these are the and also the charging can be characterized on the basis of voltage level 1, level 2 and level 3. Level 1, the voltage level will be 120 degrees 120 volt AC, level 2 is 240 AC, and level 3 is some higher level like three phase charger. So it is AC to DC charger, right? And this charger get the supply from the grid, and if it is inside the vehicle, so it is called the onboard charger, and if it is outside somewhere, charging station, like charging station are the offboard charger, right? Or home, garage or office, that is so offboard chargers is like these show the charging stations, and this is onboard charger, right? So these charger, like this AC will be getting from the grid, and this AC to DC converter will able to convert this AC to DC. Then this filter must be there, power factor correction filter must be there, or DC to DC you are getting here the ripple free DC, and with the help of DC to DC converter we can change the level of DC voltage and the required voltage which is required by the electric motor, right? So this is how we can the power flow takes place. And this one of the DC to DC converter is also used to giving the supply to the electronics item inside the motor, like charger and the music system and all. So this small rating of DC to DC converter is used for this. So it is only carry the unidirectional power flow, but in the electric motor this double shows the bidirectional power flow, because of the when the braking will be takes place by the person who is sitting in the vehicle, so the energy will be flow from electric motor to the converter side, right? So that's why it is showing here the double arrow direction, right? So this is these are the components in electric vehicles, the battery, and this DC to AC will be giving the supply as per the motor requirement. Like in the BLDC motor, the BLDC motor always come with this DC to AC inverter, because it's BLDC, it's actually the the synchronous motor, right? So the commutation process is only electronically through this DC to AC converters, right? So this must be required for to drive this the BLDC motor, right? And this this DC is powered by this the power bank, and this will charge through this charger that will carry the AC to DC converter. Then the power factor correction will be there to filter out the AC components, and then final DC to DC converter to boost the voltage level of DC, so that um, it will give you the supply to the electric motor as per the requirement of the torque, right? So and this DC to DC is only unidirection, but it is a low level voltage. That's why we need a DC to DC converter. This DC must be this buck converter actually. This DC must be changed to the low level of DC, and that can be utilized for the electronic item which is inside the motor, like the heater, the light, the aux component, or the charging, or the music system. So if you come in detail, like the traction battery pack, the DC to DC converter, the electric motor, power inverter, charging ports, onboard charger, controller, auxiliary batteries, thermal system, and the transmission. So as I previously discussed, like battery pack is also known as the electric vehicle battery pack. It powers the electric motor on the electric vehicle, and the battery act as an electric storage system. It store energy in the form of DC current, and the range will be higher with increasing kilowatt of the battery. The life and the operation of the battery depends upon its design, obviously, and the lifetime of the traction battery pack is maybe a 2000 or 2 lakh miles, right? And DC to DC converter is also required for this. It's also the very important component in the vehicle, because the battery pack delivers a constant voltage, but different components of the vehicle has different requirements. So DC to DC converter, as I said here, one DC to DC converter is here to to provide the supply to the motor as per the. So it must be a DC to DC boost converter, and this must be a DC to DC low level low voltage converter, like buck converters. So it provides the low voltage to this. An electric motor, it's a main part of the motor. Later we will discuss what kind of motor we will use in the electric vehicle, and what are the features, and why we use what are the features, and what are the importance of this motors, right? So basically this BLDC, the switch reluctance motor, the permanent magnet synchronous motor, and the induction motor is still used in the electric. Some of the company are using the induction motor also. It's a very rugged motor, right? And switch reluctances also are in the research topic of EV, because some of the companies are using the switch reluctance motor, right? But the problem in the switch reluctance motor, it has like it has a torque ripples are there, so it's become bit noisy, right? So vehicle become bit noisy due to the use of switch reluctance motor. And BLDC motor is also a demanding motor for EV companies, because the torque performance is it's good. I like the torque is according to the vehicle requirement, fulfill the vehicle requirement, and but the controlling part is bit complicated, right? Permanent magnet is also used by some of the companies, permanent magnet synchronous motor, because it is the range of the speed can be achieved easily with this, and it's a light in weight because it uses the permanent magnet, but the problem is it's high in cost, right? So some of the electric motors used. So in the electric traction motor is the main component of the electric vehicle, as you have seen in the previous slides. The motor converts the electric energy into the kinetic energy. This energy rotates the wheels, and the electric motor is the main component of the differentiate an electric car from conventional car, right? So features of electric motor is that it should be a regenerative braking mechanism, right? So that regenerative braking can be utilized to charge the battery also. This mechanism show down the vehicle by converting its electrical energy into the another form or storing it for future use. And there is two types of motor, DC or AC can be used, right? So power inverter is also important part, because with the help of battery we can provide the DC supply, but the motor, if you are using the AC motors, so inside the motor it require the AC supply, right? So there must be a converter which convert DC to AC, that can be utilized by the that can be powered to the motor. So AC current generated during the regenerative braking to the DC current. This is further used for recharge the battery also, right? So onboard charger is used to convert the AC supply receiving from the grid or the charging port to the DC supply, right? As here, if you see in the architecture, this is the onboard charger, right? So onboard charger carry the AC to DC converter, and the AC supply is coming from the grid, and then the filter, the power this filter, and that DC to DC converter. So it's a power. So it's a charger actually, right? So onboard charger is used to convert the AC supply receiving from the charging port to the DC supply, and the onboard charger is located and installed inside the car, and it monitors various battery characteristic and control the current flowing, right? And the last is the charging port. The charging port connect the electric vehicle to the external supply, and it charges the battery pack, right? And the charge port is sometimes located in front of or rear part of the vehicle. The controller, the power electronics controller, determine the working of the electric car. It performs the regulations of electrical energy from the batteries to the electric motor. And though sometimes some auxiliary or small size battery can be used, auxiliary battery on the source of electrical energy for the accessories in electric vehicle. In the absence of main battery, the auxiliary battery will continue to charge the car, right? So it prevent the voltage drop also, right? Some of the cooling arrangement is also there, which is not shown in the diagram, but some cooling arrangement should be there to maintain the temperature of the component inside the vehicle, right? And the transmission system is there. That is the mechanical part. So right now we'll stopping here. In the next class we will start the drive technologies. Thank you.